So this example is going to look at evaluating a definite integral, and I think partial fraction decomposition is going to show up here. So when we look at factoring the denominator, it'll factor into 4x plus 1 times x plus 1. Write it as two separate fractions. Solve for the constants a and b. I invite you to pause the video, and if you don't agree with what I've got here, you can pause the video and check. So now what we're going to do is finish the problem here by finding the antiderivative and then evaluating at the upper and the lower limits that we have here. So let's start with the last expression here first. The antiderivative of 1 over x plus 1 dx from 0 to 2 will be the natural log of the absolute value of x plus 1 evaluated between 2 and 0. We're going to subtract that from this thing that we have right here. So let's pull that 4 out in front. And we're going to rewrite this here as, now we'd have a 1 left in the numerator. We can let u be the denominator. If we think about it, what we're doing is we're saying that u is equal to 4x plus 1. That means the du will equal 4 dx. And this dx that we have back here, that'll be a quarter of du. That means that we can rewrite this, pull the 1/4 out in front. 1/4 of 4 times du is the same as dx. If x were equal to 0, then u would equal 4 times 0 plus 1. If x were equal to 2, then u would equal 4 times 2, or 8 plus 1, which would be 9. So when we find the antiderivative of this, we're going to get the natural logarithm of the absolute value of u evaluated between 9 and 1, minus the natural logarithm of the absolute value of x plus 1 evaluated between 2 and 0. Simplifying then, we're going to have the natural logarithm of 9 minus the natural logarithm of 1, minus, here we'll have the natural logarithm of 3 minus the natural logarithm of 1. We call it the natural logarithm of 1 is equal to 0, because e to the 0 is equal to 1. And so what we have is the natural logarithm of 9 minus the natural logarithm of 3. That's the same as the natural logarithm of 9 over 3 using properties of logs. So the natural logarithm of 3 should be our answer here. We can confirm that that is the case using our calculator. If we look at the natural logarithm of 3, we get a little more than 1.098. If we were to find the integral from 0 to 2 of our expression with respect to x, we get the same decimal approximation that we did when we did it by hand here.